For today's video, we are going to talk about simplifying expressions. So our learning target today is I can simplify expressions by combining like terms. Please make sure you write down the date that you're watching this video. For your I know, well, you know what simplify means. You know what an expression is. The new thing today really is combining like terms. So for your I know, you should be writing something about what you know about simplify or expressions. We have 3 vocabulary words today. The first one is like terms. Like terms are terms with the exact same variable. A coefficient is a number placed in front of a variable. It means to multiply the variable. And a constant is a number on its own. So at this point, please pause the video, write down all of that, and then restart the video when you are ready. So as we get started with simplifying expressions, when we are told to simplify an expression, simplify does not mean to solve. When we are simplifying something, we are making it more simple, but our answers are going to be an expression. It's not just going to be a single number. So let's look at the expression 3x plus x plus 5. Okay? When we look at this expression, the 3x, the x, and the 5 are all known as terms. These are the sections, the different sections of the expression that are separated by an addition or a subtraction. They're all known as terms. Like terms, then, are terms with the exact same variable. So in this case, 3x has the variable x, and x has the variable x. So these two would be known as like terms. For coefficients, the only coefficient we have is the number 3, because that is the number that is in front of a variable. And then the number 5 is a constant because it is a number by itself. So that is what our words that are in our vocabulary mean. We have coefficient of 3. 3x and x are like terms. 5 is a constant. Okay? So when we have a problem that says to simplify by combining like terms, so let's look still at this one, 3x plus x plus 5. In this case, my like terms are the 3x and the x. Those are like terms because they both include the variable x. So here I'll do 3x plus x, and I want to know what that is. Well, if I have 3 x's and I add another x, that gives me 4x. Then I have 4x plus 5. Now 4x and 5, those are not like terms because 5 is a constant. It does not have a variable, and the 4x has a variable. So because of that, since we have no more like terms, this is our answer, 4x plus 5. Like I said before, our answer is an expression. Okay? Looking at another example here. We're going to do this time 3x plus 6 plus 2y plus 4x. For this example, again, we want to start by combining like terms. So here I have 3x, 4x. Those are like terms. They both include x. So I can do 3x plus 4x. That gives me 7x. My remaining terms are plus 6 and plus 2y. Now I see right away I have 7x plus 6 plus 2y, but y and x, those are different variables. So because those are different variables, I cannot combine those terms. I also can't combine the 6 because it's a constant and has no variable. So at this point, none of these are like terms at all. So this is the final answer. Now, there may also be times where you see subtractions, and there's a really good trick to use here for subtraction I want to show you. So let's say we have the problem 5y minus 4y plus 7 minus 15x. One really good strategy anytime you see subtractions when you're simplifying expressions is to always turn subtraction into adding the opposite, just like we did with integers. The reason for that is we're going to have negative numbers, but it's also going to make it a lot easier to keep track of what's happening. If we turn everything into addition, so all our terms are being added, we no longer have to worry about what's being added and what's being subtracted. So instead of 5y minus 4y, I'm going to do 5y plus negative 4y. And then instead of 7 minus 15x, I'm going to do 7 plus negative 15x. Now looking for like terms, I see that I have 5y and I have negative 4y, okay? 5y plus negative 4y, that's going to give me 1y. Then I still have plus 7 plus negative 15x. The nice thing about turning it all into addition is I don't have to worry about what operation now goes between my terms. It's always going to be addition. This can actually also be rewritten. 1y is just y, so I could just write this as y plus 7 plus negative 15x, but in reality, both of these would be considered equally good answers. Now, one thing that's really, really, really important when you're simplifying expressions is that when we're doing the turning subtractions into adding the opposite, this is really important in especially longer, more complicated expressions. So let's say, for example, we have the expression negative 2 plus 5z minus 2, and then in parentheses, z plus 11. Now, I always, always, always want to start by turning my subtractions into adding the opposite. This is especially important when there is a distributive property involved. So instead of subtracting here, I'm going to turn this to adding negative 2. That's my only subtraction. So now the next thing I need to do, when I see that I have those parentheses, I need to worry about this first. And here's where that distributive property we learned in the last video is really, really important. So here we're going to do negative 2 times z. That's negative 2z. And we're going to do negative 2 times 11. Well, negative 2 times 11 is negative 22. And we have our addition. Now, again, it's really nice. Instead of having to worry about what operation I'm bringing down, I just bring down all addition. So I have negative 2 plus 5z plus negative 2z plus negative 22. Still looking to find like terms. I see that I have a 5z and a negative 2z, so I can combine those. 5z plus negative 2z will be 3z. And I still have left a negative 22, negative 2. Now I have two constants, two numbers without a letter involved, a variable involved. I can actually combine those as well. Negative 2 plus negative 22, that's negative 24 plus 3z. And that's my final answer. Now maybe you wrote your final answer as 3z plus negative 24. In that case, both of these are accurate because of the distributive property, which says that with addition, we can change the order. So whether you wrote your answer as negative 24 plus 3z or as 3z plus negative 24, either of those are exactly perfect, okay? Last thing I want to show you is, let's say we had a problem that was something like this. Okay? Here I have 8xy plus 2x plus 3y plus 7x plus, let's say, 4y squared. Okay? Here I have a lot of terms. The important thing with combining like terms is that the like terms means the exact same variable. So in this case, y, that's not the same as x, so that can't be combined. It's not the same as y, so that can't be combined. The only things in this expression that I have to combine are my 2x and my 7x. 2x plus 7x, that's 9x. But if I then bring down everything else, I have 8xy, 3y, and my 4y squared. Y squared and y are not the same. And 8xy, that can't be combined with just x's or y. So this expression actually be by itself. So really important that you remember only exact same variables count. Please rewatch or let me know if you have any questions, if there's anything you're confused about. And thank you so much for watching and have a great day.